Hi friends, Naji here. Welcome to my YouTube channel. In our last few videos, we have discussed about LangChain, and basically we discussed about what is a runnables, and we discussed about different kind of loaders, splitters, and different techniques in what we call the embedding, different embedding techniques. Then we discussed about different storage system, right? In this video, we are going to make use of all those expertise, and we are going to build an application that is chat with HTML web page. So in a rack, we know that we can split into two steps. The first step is a data ingestion step in which we will be loading the data, we will be splitting the data, we will be creating the embeddings, and we will be store the data. So in the second step, we will have a retriever and generation in which we will have a question that user will ask some question. The question will be run or run against the retriever. So retriever will generate some document based on the similarity, and we will have a prompt, and this question will be passed to the LLM. Okay, so we can see this graph. It will have the question will be here, prompt will be here, and the document retriever from the storage also passed to the LLM model. Then LLM model will generate answer for us. Okay, so how we are going to achieve that? So we will be using a web-based loader. As I mentioned, we are going to use a web page chatter, right? So we are going to use of web-based loader, which will help us to download, or which will help us to create the document of that particular web page. Then we will be using RecursiveCharacterTextSplitter, and our vector store will be InMemoryStore. Then we will have a retriever and the generator. So retriever and generator, we will be using the LangGraph. And if you are not aware of LangGraph, which is very simple, I will explain that in detail. And you guys can also check my channel. I have created a dedicated playlist for LangGraph. So this is a QA pipeline with LangGraph. So we will have a starting node, and we will have a retriever node, and we will have a generator node, and we will have a stop node. Okay, and we can see a state. So this is actually a memory. This memory is shared among the LangGraph. So whenever a state update is happening, the retrieval will update that into the state. Okay, and which later can be accessed by the generator. Okay, so in this way, this is a shared, or we can say it's a shared memory. Okay, and we can say whenever a query is passed to a retriever will generate the document, relevant document. That document will be passed to the state. Okay, then in the next step, generator will to generate the answer. What generator will do is generator will get the relevant document that is retrieved in this part from the state. Then that will be passed to the LLM. Then LLM will generate the answer for us. So this is the basic workflow. So we can start coding, and maybe during that time it will be more clear. Okay, so what I have done, I have my Visual Studio Code is open here, and this is the web-based URL that we are going to do the rack. So let me copy this. I think I have already opened that. So let me check here. So this is the HR leave policy for employee. So this is what we are going to download, and we are going to do a Q&A against this particular web page. Okay, and for that, as I mentioned, I will be using web-based loader. So we can start importing few things. Okay, so from LangChain community, we will have a document loaders first, and we can import the web-based loader. Okay, and I can import base64. Okay, now let me go to here. So this is our HR policy document. Here we are not going to load everything. So we will be loading only based on a specific class. So this is the class that we are going to load. Okay, so let me copy it. Let me go back. Here I can create a loader. So loader will be web-based loader. Here I can pass the web path. So the URL will be our web path. Now I can set the basics BS argument, in which I can pass the dictionary. Okay, here I can say that parts only. So we will have a beautiful soup. soup strainer. Here I can pass the class that I need to parse. Okay, let me paste it. So this is the class that we are going to parse from the web page. Okay, so let me check this class. Here we have the closing, here we have the closing. Let me see why we are getting the error. So this should be a dictionary. That's why. Okay, so loading is done. So we can check the length of. Okay, so we have the loader. Now we can load the document. So for that I can use the loader.load. This will load the document. Okay, I can print the doc here. So this is the document. Okay, now we can do a splitter. So for the splitting part, what I am going to do, I am going to use the LangChain text splitters. Okay, here I can import recursive character splitter, and from OpenAI I can use embedding LangChain underscore OpenAI. I can import OpenAI embeddings, and I can import chat OpenAI. Now let me have the embedding. So embedding will be, I can have a OpenAI embedding, and chat model I am going to use. Here I can have a model. So model I am going to use chat OpenAI. We can use GPT-4 or mini. Okay, it says init argument to work. So embedding is the OpenAI embedding. So this will use the default embedding model, and here I am using the chat OpenAI. It should be working. Let me run it again. Okay, so that is working. So this is the problem. Let me check what is the problem. Here we have a chat OpenAI. Chat OpenAI GPT. Okay, maybe model. I can say model equal to GPT-4 or mini. Let me run it again. Okay, so that's the result. So we have our embedding and we have our model. Now we can split the document. So I can use the all split. What I can do a recursive character splitter, in which I can use a chunk size of 2000, and I can use a chunk overlap which is equal to 200. Okay, I can use a split document. Now I can pass the document that is created. So we'll see. So here the chunk size spelling is wrong, that's the reason, and I can check the length of all splits. Okay, so we have 14 splits are there. Okay, now once the splitting is done, we can do a storage, right? We can save it into a storage. For that we will be using the in-memory vector store. Okay, import in-memory vector store. So our vector store will be vector store. I can use a in-memory vector store. Embedding will be our embedding. So once that is done, we can add the document. We can add the document that is all split. All split. Okay. So this will be added. We can check. Okay, so we have got all the details and everything is updated to the vector store. Now we can do a similarity search here. Just to see similarity search, I can ask for what is LOP. We'll see what all the document that we are getting. So we are getting about other leave or paid or unpaid. That is a one document says and the other one says conclusion, and the third one says higher productivity and HRLE policy. Okay, it is returning something. So we'll see what is the actual answer later. Okay, now what we can do, we can create the LangGraph. For that we can have a typings, and I can import type dict can be imported. This will be used for the create the session type dict, and we can import the LangGraph dot graph. I can import graph, and we will have a start, end, and we need to have a state graph. So we are defining the graph now. Okay, for that first I can create a state. So this is the state that we are going to save the all the we can say it is a memory in a layman view. So we have a question here, and we will be keeping the context also here. And we will be keeping the answer also in this state. Okay, so once that is done, we can define the retriever method. Now I am going to define a retrieve. Okay, so this will be a state. We are passing the state here. I need a query, right? The query will be, we will get the query from here, from the state. So since I already have the state here, I can directly get the question from here. So in the retriever we have the query. Now I can do a retrieval doc. For that I can use the vector store dot similarity search. I can pass the query. Okay, so once we have the query, we will have the retrieved document. Now what I am going to do, I am going to make little bit of change for this retrieved document. For that I am going to create a method that is called the process doc. I will be passing the retrieved doc here. Okay, now let me create a method. Process document. Okay, in which we will be getting retrieved doc. Okay, so we will be converting this into a text, or by looping through all the page content. So I can mention it like selection. I can do a join for doc in retrieve doc. I can create a doc.page content. So we are only taking the doc.page content. Now returning the doc text. Okay, so once we have the retriever, now we need to update this into the state, right? So to update the state, I can just return this. I'm going to update the context. The context will be doc text. Okay, now our retriever is ready. Okay, I can say it is a retriever. So let me explain it again. So we will have a state. The state is a kind of a session that we are going to keep, and the state contain a question, and it contain a context, and it contain an answer. Okay, now we will have a retriever. Retriever is also getting the state. Okay, so this is shared by the LangGraph, and from the state it will get the question here or the query here. So based on that, we will be doing a similarity search with respect to the vector store. Then we will have the retrieved document. So this document has a metadata information, and this document is also have the page content. So I don't need the metadata information for this particular requirement. So what I'm doing a processing of this document and creating a document text which contain only the page content. Okay, so once that is done, we need to update this back to the state, right? For that I am returning this like a context equal to doc text. So this will automatically update to the context. Okay, so that is how the retriever work. Now once the retriever is done, what we can do, we can create the generator also. For that we have to do few import. So let me do few import here. I can do a langchain.schema. I can import human message, AA message, and I can have a system message. Now from langchain, so we already have the model is ready, so this is not needed. Okay, now I can use a generator. So generator also will have a state. We will have a state. The state will be passed from the retriever. So what I can do, I can create, we already have the model. Now I can create a message. So this message, we will have a system message. In the system message content, okay, I am going to say we will have the state context, right? So I can say that as a state context. Maybe let me rewrite it again. So here I can say that based on the context, from where we will get the context, we will get the context from the state. State has the context. I can say that based on the context, answer to the question. Don't can say the hallucinate. So this is my system message. Now I can give the human message. So human message is content, and this will be our query. So we will get the query from the state, that is the question. Now I can create a response. I can create a model.invoke. Now I can pass the message. So this message contains the document and the prompt, and it contains the question. Okay. So once that is done, what I can do, I can return. Now what we need to do? Now we need to update the answer to the state, right? For that I can have a answer. This can be updated back, right? Answer. This will be our response. Okay, something is there, so let me check that. Here we have the context is there, f string matching, so something is not correct here. The content, here we have the context, that is also right. Maybe we have to use the single quote here. Execute it. Okay, so execution is done. Now we have the retriever and we have the generator. Now we can start building our graph. Okay, so let me create a graph. I can say it is a builder. This is the standard template that I am using, so I want to use the same variable. Can use the state graph. We are passing the state. Now I can have a builder.add node. Okay, so first it will be this will be a retriever node. Retriever. Now I can add another edge. Add node. This will be generator. This will be our generator. So we have our node is ready. Now we can build the edges. Add edge. So first edge will be the start node, right? If you are remembering that diagram that I have shown, it will have a start node. From start node it has to go to the retriever, right? So from retriever you will go to the generator. Okay, from generator we are going to end it. Okay, so we are done with the building the edges. Okay, now what we can do, now we can compile the graph. So builder dot compile it. So the compilation is done. Now we can start invoking. Okay, graph dot invoke. Okay, we need to pass the question. The question will be question. I can ask what is LOP. What is LOP? Okay, so if we are asking like this, what is happening is, so the graph knows the state is our session, right? So it will automatically go and update this question to the state, and the retriever from get the question from here. Okay, and what happens is that once the document is retrieved, it will update the context. Okay, it will update the state with the context, then generator will able to get the context and the question from here. Okay, so that is how the session is working. So now let me execute it. So the execution is progress. See, LOP stands for loss of pay. It refers to a type of leave taken by the employee without prior permission and considered as a necessary task. Okay, so this seems to be a good answer for us. Now we can see how. So this is actually giving the entire answers together. Now we can see how can we create a streams of data. Okay, for that, which is also very simple, I can create a chunk and I can use a metadata. Okay, we need to use graph.stream method. Okay, here we need to pass our question. Within this we can pass the question. The question will be what is LOP? What is LOP? I can say. So once this is done, I can mention the stream mode as message. We need only the message. So okay, now I can check if is instant. Now we need to check only the AA message only, right? We don't need any other message. So let me check a validation here is if chunk is a AA message, then only we need to print the result. I can print as a chunk. Now let me execute it. See, we'll able to see the details, right? See LOP loss. So here what I can do, I can print only chunk.content. Let me execute it. See, it is streaming the data. LOP stand for, then to make it little bit more clear, I can make end as space, end equal to space. So this will be more clear. We'll see how this works. See, LOP stand for loss of pay. It refers to the type of the leave taken by the employee, and even if the employee is on leave balance available, the company may clarify the leave as LOP due to the lack of communication, which could disrupt the workflow of effective the task completion. Okay, so this is actually giving us a good answer, and this, I believe this seems to be correct. Okay, so that is all about in this video. So what we have done, we have actually explained about the LangGraph QA pipeline. Here first we have completed the data injection part. Data injection, we have used the WebBaseLoader and the RecursiveCharacterTextSplitter. Then we saved it into a vector store. Okay, once that is done, we created a LangGraph with generator. So if we come here, we can see a LangGraph with a retriever and generator, and we try to see how can we invoke the graph, and we also done the streaming of the data also. So that's it. Please do like and subscribe. Have a nice day. Bye bye.